Hello and welcome. Today I am going to be walking you through a PyReason pet store tutorial. The full link to the full code shown in this example will be in the description below and also included on our GitHub and or our website. Let's get started. So first, a brief overview of what I will be talking about today. Number one, how to create a graph using NetworkX in PyReason. Number two, how to add rules, facts, and annotations in annotation functions in PyReason. Then how to run PyReason. And then finally, how to get and read explainable output from PyReason's explainable reasoning process. So let's get into it. So our real world example or problem we're going to be thinking about today is imagine you own a pet store and you're searching for more customers. You have a database of people, their pets, and their friends, and you're searching for potential customers by finding people who are friends with customers. And then you're also searching for target customers by finding people who have at least two friends who are customers and they have the same pet as at least one of these friends who are already customers. So we're looking for potential customers, which are basically the friends of your current customers. And then target customers are people who have multiple friends who are already customers and the same pet as someone, at least one of those friends. So I'm going to show you how to use PyReason to create rules, facts, and annotation functions that will search and traverse your database, making these connections and then giving you answers as to what people in your network are potential customers and what people are target customers. So let's get started. So first and foremost, we need to create a graph. Graphs are the knowledge base. In PyReason, you can create a graph manually through NetworkX. You can also load in a graph using GraphML file, but today we're going to create a graph manually so we can see a little bit more how everything's working. So first, I'm going to add my people. I have John, Mary, Justin, Alice, Bob, Eva, Mike. The names are not important, but I have my people details. Next, I'm going to add my pet details. So I have the types of pets and then the animal family that they fall into. So this is my node, my data for my nodes. Next, I'm going to add my data for my edges. So edges are our relationships. So some edges are our friendships. So this is kind of connecting different people in our network who are friends with each other. And this is a directed graph. So person two is friends with person one, person zero is friends with person one, etc. So on and so forth. And then also for pet ownerships. So who owns what pet? And again, this is the data for the edges in our graph. So person one owns pet two, person two owns pet one, and so on and so forth. Next, I'm going to actually create my graph and add in those nodes and edges that we just created or created the data for. Um, so yeah, I'm going to add the nodes for the people and then add the nodes for the pets and then add the edges for the relationships. And this is all building a graph using NetworkX. And then here is a nice picture of our graph. So as you can see, we have pets and people, our nodes, and then we have, it's a directed graph, so we have the relationships between them. So person zero is pointing to pet zero. That means that person zero owns pet zero. Person zero is also pointing to person two. That means that person zero is friends with person two. Person four points to person zero. That means person four is friends with person zero, and so on and so forth. So these edges are either pet ownership if it's going from a person to a pet, or friendship if it's going from a person to a person. So let's get into the real PyReason nitty-gritty here. So first we need to initialize PyReason. We're going to use the load graph function because we created this graph ourselves with NetworkX. And then we're going to make sure that we initialize the settings. So we're going to set verbose to true and then set our atom trace to true because we want to be tracing our output. Next, let's add some rules. So the rules that we're going to add are kind of the objectives that I talked about at the beginning. So I'm going to have two rules, the potential customer rule and the target customer rule. So rules in PyReason are used to create or modify predicate bounds associated with nodes or edges in the graph if the conditions in the rule body are met. So for the potential customer rule, a customer is a potential customer, which is the head of the rule. The head always comes first. If they have friends, have a friend, at least one friend who is already a customer, then the person becomes a potential customer. And then for our target customer rule, it's a little bit more complicated. So when a person becomes a potential customer, they get put through an annotation function, which I will mention in a minute. So a person is a target customer if after becoming a potential customer, meaning they have at least one friend who is a target customer, they have a bound from between 0.5 and 1, or a bound inside the range 0.5 and 1 from their potential customer, and at least one of their friends owns the same pet as them, then they become a target customer. So again, we have target customer is the head of the rule, and it is only satisfied, which means that it's going to modify or create predicate bounds, 0, 0 being false, 1, 1 being true, and so on and so forth. PyReason allows there to be a range in between. It's only going to modify this target customer rule from 0, 1, which is the default, to 1, 1 if the potential customer range is the bound is in between 0.5 and 1, and also if one of their friends who is a customer owns the same pet as them. So this will make more sense when we get to use it on our real world example, but this is kind of an overview of the rules we're going to add to our graph. So next, let's talk about facts. All right. So facts in PyReason are, excuse me, are statements that store information in the graph. So it's a basic unit of knowledge. And as you can see here, it kind of initializes some sort of form of knowledge. So we add two facts in this example, one of which initializes person 0 to be a customer at time step 0, so immediately, and then person 2 is a customer at time step 1. So these kind of initialize pieces of information in the graph. All right, finally, we're going to talk about annotation functions, and then we're going to look at some code. Great. All right. One second. Okay, annotation functions are specific user-defined Python functions that are called when all the clauses in a rule have been satisfied to annotate or give specific bounds to the head of the rule. So annotation functions have access to the bounds of the grounded atom for each clause in the rule, and users can use these bounds to make an annotation for the target of the rule. So basically, if you users of PyReason are able to write annotation functions which will specify how the bounds of the head of the rule are impacted if all the clauses of the rule are met. So in our case, if we remember our rule function, our potential customer rule had an annotation function, potential customer annotation. So if all the clauses in the potential customer rule were met, then the bounds of the head of the rule, so potential customer, would be altered in the following way. So for this, we want to see how many friends each customer has who are also customers. So we know that in order for a potential customer rule to be satisfied, they need to have at least one friend who's a customer. But for our target customers, we want it a little bit more. So now we're going to find the number of friends that are customers by accessing the annotation, which is the list of grounded atoms. Um, and we are going to access them and count them. And that's going to be the number of friends that a given person has who are also customers. So if a person has greater than at least 2 friends who are already customers, then we're going to set their bound, their annotated bound, to be 0.5 as their lower bound and 1 as their upper bound. And otherwise, meaning that they have 1 or less friends who are already customers, their bounds are going to be set to 0, 0. So that is how that annotation function works. Now let's pause and let's look at some code. Okay. So this is all the code that you've seen before. Here's us adding in our customer data, our edge data, creating our actual graph. But what I want to show you is here is our annotation function. And then the way that you add an annotation function to PyReason is you call this add annotation function and the name of the function. And then if you remember in PyReason add rule, if all of the clauses in potential customer rule are satisfied, meaning the person has at least one friend who's a customer, then the annotation function runs and modifies or annotates the bounds of potential customer based on how many friends who are already customers the now potential customer has. So that is why in our target customer rule, we check to see if any target customer is already a potential customer. So we check to see if the potential customer's bounds were annotated to be 0.5 or 1, meaning that this person already has at least two friends who are customers, which is one of the requirements for being a target customer. Great, and then here are our facts. So again, we just initialize customer person 0 to be a customer at time step 1 and person 2 to be a customer at time step 1. Time step 0 for the first one if I said that wrong. All right, now let's see how we run PyReason. Oops, all right. Let's go back here. Slideshow. Running PyReason. Okay. So we're going to run this interpretation over one time step. If you're doing a more complex reasoning process, you might need to run it over more time steps, but for our purposes, one will suffice. And then now let's look at our explainable output. So when we run PyReason, what people that we initialized in our graph are going to be found as potential customers and what are going to be found as target customers. So let's get into it. The first way to breed PyReason expected output is by using our interpretation get dictionary function. So this outputs a dictionary that is triply nested from time to graph component to predicate bound pair. So let's see what it looks like if we run this get dict function on our interpretation. So we're gonna go back to code. Great. Okay. So if I scroll down here, I have my run the PyReason, perform the reasoning over one time step, and then I have my interpretations get dict, and then I use pbprint to print it out nicely. And then here is my triply nested dictionary. So as you can see, the outermost part of the dictionary is a time, so 0 and 1, and then it goes graph component, and then it goes to the predicate bound pairs. So as we can see, at time 0, we have person 1 becomes a customer with their bounds 0, 0 because it's true that they're a customer. And then we see also at time 0, person 4 becomes a potential customer and person 6 becomes a potential customer. And that is because if we look up here, we can see that person in friendships, we can see that person 4 is friends with person 0 and person 6 is friends with person 0. So they're going to become potential customers immediately. Next, we move on to nothing else changes in this first time step. Next, we're going to move on to the first time step in which we also initialize person 2 as a customer. So now person 1 becomes a customer, potential customer, which is a little bit redundant, but it happens because person 0, I should say, because person 0 is friends with person 2. And then we see that so now person 2 is a customer because of our fact. And then person 4 is potential customer instead of having the bounds 0, 0. Now person 4, because of our annotation function, the potential customer rule has the annotated bounds 0.5 and 1. And this is because person 4 is friends with person 2 and person 4 is friends with person 1. So now once person 2 becomes a customer, person 4 has two friends who are customers. So therefore, all the clauses in the target customer rule are satisfied, and person four becomes a target customer as well, because the final clause is that person, the person needs to have the same pet as at least one of their friends who's a customer. And person four has pet four, and person zero also has pet four. All right, we'll go over this again. And then finally, person six is still just a potential customer. Their bounds do not get further annotated after customer two becomes a customer because person six is not friends with person two. All right, great. So that is how you read the interpretation. That's how you read the get dict function. We also have some other new functions on how to that will help you read PyReason's explainable output. All right, so the next are these kind of trace explainable output functions. So the first is filter and sort nodes. So filter and sort nodes is going to filter, um, it's going to filter and sort the node changes in the interpretation and return it as a list of pandas data frames that contain the filtered and sorted interpretations. And they're going to be easy to access. So in our example, we are going to filter and sort nodes based on the nodes that change to become potential customers or target customers. So let's take a look at that in our code. Let's see. Sorry for all the clicking around. Okay. So if we go here, we have our data frame one is going to be, so make sure you assign it to a pandas data frame, and then you can just print out your pandas data frame. Um, and then filter and sort nodes is going to be potential customer, target customer. So as you can see, here is our filtered and sorted nodes. So at time step 0, person 4 and person 6 become potential customers. So they both show up, but none of them have two friends who are customers already. So their bounds are going to be 0, 0. And then neither of them are target customers. So their bounds are going to be 0, 1, which is the default. And then in time step 2, we can see person 4 bounds get annotated because it passes the annotation function and therefore also becomes a target function, a target customer, making the bounds 1, 1, which is true. And then person 6 remains just a potential customer, not a target customer. And same with person 0, just a potential customer, not a target customer. So that is how you read filter and sort nodes. PyReason also supports filter and sort edges, but we don't alter any edges in this graph, so it's not necessary. It would be an empty data frame. All right, and then finally, we have our get and save rule trace. So our get and save rule trace function saves the rule trace and saves it to a CSV file that is very readable. So the columns in the CSV file are first the time, then the fixed point operations. This is where the reasoning stabilizes, the edge or node that has changed, the label, so this is the head of the rule, and then the old bound versus the new bound, and then why this change occurred, and then finally what grounded the clause in the rule. So let's take a look at our CSV if we run the function save rule trace on our reasoning. So as you can see, I run save rule trace here. And then again, none of our edges change. So this does it for nodes and edges, but our CSV file for save rule trace edges is going to be empty, but our rule trace for save edges, is not empty. Let me move this down so you can see it. I don't know if you can see the screen sharing button. Anyways, for nodes is not empty. So this first column is time. Again, we only run it on up to time step 1, so we only have 0 and 1. Fixed point operation, node, label, old bound, etc. So our first change is at time step 0, we see person 0 becomes a customer. So the bounds change from 0, 1 to 1, 1. And this is due to the customer fact. Great. And then from at also time 0, person 4 becomes a potential customer, so changes the bounds from 0, 1 to 0, 0 because of the annotation function. And this is due to the potential customer rule because person 4 is friends with person 0. Same is true for person 6. We can see that this is because person 6 is friends with person 0. So this is really helpful because you can see exactly what rule or fact has changed the bounds, and then also it tells you why. Next, at time step 1, person 0 is still a customer. That fact still applies. And then now person 2 also becomes a customer because of our customer fact. And then this changes person 4. So now person 4 is a potential customer still, but now its bounds get annotated to instead of to 0, 0 to 0.50 because if we remember in our annotation function, person 4 is friends with person 0 and person 4 is friends with person 2. So now it has at least 2 friends who are customers and therefore becomes eligible for its bounds to be annotated. Next, person 6 remains a potential customer. And again, its bounds get annotated 0, 0 because its friend who is a customer is still only person 0. And then finally, now person 0 is also a potential customer because person 0 is friends with person 2. So even though it was a customer, person 0 is now also a potential customer. And then finally, person 4 becomes a target customer because which changes its bounds from 0, 1, the default, to 1, 1, so true. Because of the target customer rule, because person 4 is friends with person 0, and person 4 is also friends with person 2, so its bounds got annotated to be 0.51 on the potential customer rule. And then person 0, a customer, has pet 4, and person 4 has pet 4. So now person 4 has 2 friends who are customers. So it's in the potential customer rule, its bounds get annotated to 0.5 and 1. And person 4 has the same pet as one of its other customer friends, person 0. And so person 4 is our target customer. And person 6 is our potential customer. All right. Again, you can find the full code linked in the description below. I hope you enjoyed this tutorial on kind of a real world example of how to use PyReason. And please comment any questions, suggestions, etc. below. Yeah, take care. Have a wonderful rest of your day.